Hi, this is Mrs. Lloyd with Lesson 1-2, Day 2, Linearity, Intercepts, and Symmetry. Today's focus will be on symmetry. Three types of symmetry we're going to look at: point symmetry, line symmetry, and sometimes there's just no symmetry. Identify the type of symmetry in the graph of each function and explain what is going on. So let's look at these. You might want to draw these graphs so you can think about them. So point symmetry says that there is a point that I could put on the graph and rotate the graph 180 degrees and I would have the same graph. Line symmetry says that there's a line, a vertical line that we could draw, and if we could fold the graph, it would be mirrored on that line or fold up onto itself. So if we look at the first one, if I drew a vertical line and I folded this one, I hope you see that it would not fold onto itself. So it is not line symmetry. But if I tried to rotate around a point, perhaps that point, 180 degrees, I would get the same line. So this is point symmetry. In the second graph, if I drew a vertical line, is the graph mirrored across that line? Yes, so that is line symmetry. Sketch these two graphs and we'll talk about these. So on example C, I don't think there's a point anywhere on this that I could rotate and get 180 degrees and get the same graph. And I also don't think there's any kind of vertical line that when I would fold, I would get a mirror image. So I would say that C has no symmetry. And D. I think D could be tricky because it somewhat looks like it would have no symmetry. But what if I extended this graph, because it does extend, just so those are about the same length. A vertical line does not mirror, so it is not line symmetry. However, if I rotated around this point 180 degrees, I would get the same graph. So this one is point symmetry. And the other thing we're going to talk about today are even and odd functions. Functions that have line symmetry with respect to the y-axis are called even functions. So line symmetry with respect to the y-axis are even functions. And we can do the algebra if we don't have the graph to check. We can plug in a negative x for that. Functions that have point symmetry with respect to the origin are called odd functions. And so in this case, if I plug in a negative x, I should get the negative function. If I don't have a graph, that's the algebraic way to do it. And that's what we're going to look at. Now, if I had a graphing calculator and I was allowed to graph them, I would graph them. That would be the easiest thing to do. So let's look at these and see if we can, from the graphs, tell, and then we will check the algebra. Determine whether each function is even, odd, or neither, and then confirm algebraically. So let's look. It does not look like this has symmetry with respect to the y-axis, so that does not work. What about if I rotate 180 degrees or by the origin? That appears that would give me the same function. So this is odd. Now, let's check that algebraically. I'm going to substitute in a negative x. So negative x for the x raised to the third minus 4 times negative x. Negative x times negative x times negative x is negative x to the third. Negative 4 times negative x is positive 4x. And so my test is, when I plugged in a negative x, did I get the negative function? Or did every sign change? Let's check. Positive x to the third, negative x to the third. So that is opposite. Negative 4x, positive 4x. And that is opposite. So algebraically, it also shows that it is an odd function. On B, if I would rotate 180 degrees about the origin on this one, I'm not going to get the same one. But it looks like if I looked at this line symmetry, it is symmetrical to the y-axis. Let's check it algebraically. Once again, I plug in a negative x, and this time I hope to get the exact same thing. So 2 times negative x to the fourth minus 6 times negative x squared. So I'm replacing the x, just the x, with a negative x. Negative x to the fourth is negative x times negative x times negative x times negative x, which becomes positive x to the fourth. Negative x squared, negative x times negative x is positive x squared. So negative 6 times positive x squared is negative 6x squared. So in this case, f of negative x is the same thing, is equal to the function. That means that this is even. And the third one looks like it could be symmetrical. To me, it looks like it could be symmetrical about the origin almost. But I'm going to notice one thing. This goes slightly above this point, and this one is slightly below. So I don't think it is, and I know it's not symmetrical to the y-axis. So it almost looks like point symmetry, but I don't think it is. Let's check it. Substitute in a negative x for x. So negative x to the third plus 0.25 negative x squared minus 3 times negative x. Negative x times negative x times negative x is going to give me a negative x to the third. Negative x times negative x becomes positive x squared, so this is plus 0.25 x squared. And negative 3 times negative x is a positive 3x. So does f of negative x equal, we know it doesn't equal the same thing, does it equal the negative f of x? So did every sign change or become opposite? positive to negative. That one's okay. But this one is positive to positive. So no. This one is neither even or odd. So this is neither. You can also look at points and determine, assume that f is a function that contains the point 2, -5. Which of the given points must be included in the function if f is even? So if we have 2, -5, and we want it to be reflected across the y-axis, we would have to have -2, -5. And if it's odd or reflected about the origin, we would have to have, so we'd have 2, -5, so we would have to have the opposite, or -2, +5. And we will look at these in class, but if you want to go ahead and give those a try, identify the type of symmetry and state whether the graph is a function. So this is going back to using the vertical line test. Thanks for watching.